This is the last video for section 2.4 about misleading and deliberately misleading graphs. Misleading and deceptive graphs. So newspapers, magazines, and websites frequently go for the wow factor when they display graphs. The graphic designers and the editors are generally more interested in catching people's eye. So, they need money, they need their readership to stay high. So, they're more worried about that than they are making the data stand out or displaying the data in what we would consider a mathematically correct fashion. So the two most commonly used tactics are 3D graphs and pictograms. So pictogram is just a graph that uses pictures to represent the data. The use of 3D effects is discouraged because they're difficult to read. They don't really add anything to the graph, and they distract the reader from the data. Let's look at a couple examples. So in the first example, it says soccer continues to grow in popularity as a sport in the United States. By 1991, there were approximately 10 million participants in the United States aged 7 years and older. By 2009, the number had climbed to 14 million. So, somebody created the following graphic. What's wrong with this? Well, the problem is the 2009 soccer ball is 4 times as big as the 1991 ball. Why is that a problem? Well, the actual increase is 40%. How do I know it's 40%? Well, I started at 10 million and I ended up at 14 million. So it increased 4 million, and I'm going to divide that by the original amount. So the original amount was 10 million. And since we don't need the millions here. So 4 divided by 10 is 0.40, which is the same as our 40%. What about in the second example? In the second example, the figure represents the educational attainment in 2016 of adults 25 years and older who are U.S. residents. Why might this be considered misrepresentative? Well, here's the problem. Because it's 3-dimensional, it looks like this pie piece is much bigger than, say, this pie piece. Whoa, sorry, that was the wrong marker tick. It looks like the one I highlighted yellow is much bigger than this piece. But we don't necessarily know that, because the problem with 3D graphs is that they tend to overstate the size of the categories, meaning the pie pieces, closest to the reader. And that's how they get that, part of how they get that 3D effect. So that's why we should never use the 3D graphs. Well, that concludes section 2.4, which means we're done with section 2. Chapter 2, sorry. We will be talking about chapter 3 in the next set of videos, and that will be all about descriptive statistics. I will see you for the chapter 3 videos.